Okay, so where did we leave off yesterday? We left off with a couple beginning aspects. And those beginning aspects are looking at the lead term or the highest degree term of the polynomial. And it's going to tell us a couple things. If the coefficient of the lead term is positive, or the lead term itself, quote unquote, is positive, then it's going to end heading toward positive infinity. So as you look to the right, it'll end to the right, heading to positive infinity. If it is a negative lead term, it'll end or to the right, head toward negative infinity. Another thought then was also the aspect of whether the lead term had an even exponent or an odd exponent. Even exponent said it starts and finishes the same way. Odd exponent, it starts and finishes in opposite directions. So this begins to give us a picture of what we can expect of the shape of the graph. As well, as well, there's the aspect of how many possible directions. You guys are all frozen, huh? I'm not. You are. Great. I tell you. Sometimes I really wonder, but then it explains why some of you don't get it, because you're not even thinking. So, and if you don't think, you won't get it. All right. Enough for the commercial. The other aspect is how many directions is going to correspond again to the lead term's degree. And so if it's squared, you can have a max of 2 directions, cubed 3, fourth power, max of 4 directions, etc. If somebody asks you directional changes are always 1 less, so up to less than or equal to 1 less than the power. Right? So if it's 4th degree, you can have 4 directions, which could be up to 3 directional changes. 5th degree, 5 directions possible. Nothing today, thank you. And again, up to 4 directional changes. All right, so here's where we left off. We were looking at the graph. And this was the basic graph of y equals x cubed. And then we looked at the aspect of y equals x cubed plus 1. So again, the base in red is y equals x cubed. The second thing we did, was y equals x cubed plus, smarting, we love it. Go away, can't get to it. Delete, thank you. So the second one was y equals x cubed plus 2, and we found that it caused the whole function to go up 2. And don't miss this point in this key concept that every output from the red one, any point on a vertical line, the output is 2 more. So no matter what point you pick, the output is 2 more. All right, right at the bell, we were looking at the next scenario, and that was when we had y equals x times, or the quantity x minus 3 quantity cubed. And this then moved the function 3 to the right. And I think you drew that already in your notes, yes? Okay. So again, just like we're accustomed to, the h value, which corresponds again to the x coordinate, is the vertex of this, or this breakpoint is 3 to the right. The whole function is moved 3 to the right. No matter what point you pick on a horizontal line, the other one is 3 away. It's 3 to the right, 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 3 to the right. Wow, good. Glad that works. Okay, so 3 to the right. Okay, so let's look at the next function. And jump the gun on that one. The next one, so again, what's our base? Y equals x cubed. In the next situation, we've got a y equals, and I'm just going to do it in blue because I don't have green available right off the bat. So what's this negative going to do? Okay, so it's a cube term. So we expect it to go in opposite directions from lead to end, beginning to end. And it's negative in front, so we know it's going to end up heading toward negative infinity. And so, but everything else is the same. This is an x cubed, and this is an x cubed. The only difference is that negative sign, and what effect does that negative sign have on everything? And it simply causes the function to be mirrored about the x-axis, y-axis. Let's see if what I would do. Okay, so I can't remember whether it's mirrored about the x or y, because would you agree it fits both scenarios in this form of it? It fits both scenarios. So we'll look at something a little bit later that has more complexity to it and more turns, and then we'll figure out whether it's the x-axis or the y-axis. I can't remember which one is which. And again, what I would do if I wasn't sure is I would just plot something simplistic and see what it does. All right, but this is mirrored. I'm thinking about the x-axis, but we'll find out. Right, there's a reflection due to the negative. All right, let's keep rolling here. Okay, let me clear my ink. Okay, so the next base function then is y equals x cubed. And again, you should be drawing all these in your notes. Plus 3x squared plus x minus 1. Now that's, you've got that in your notes. Y equals x cubed plus 3x squared plus x minus 1. So you want to sketch that in your notes. It should start and end in opposite directions. It does. It should end heading toward positive infinity, and it does. It can have up to 3 directions, and it does. And it'll be less than or equal to 2 directional changes, and there are 2 directional changes. I also noticed that there are how many zeros on this function? How many zeros are there? Say it. 3, right? One's easy to read. X equal negative 1 is a clear 0. The other 2, I don't know the exact values of them. So look, if you were factoring this, how many binomial factors could you find? And just the answer would be just 1. You could find the x plus 1 binomial factor. The other 2 zeros, how would you have to find them? Luke? Quadratic equation, exactly, because they're not whole numbers, right? And they're not easy rational numbers. So it would take the quadratic equation to find those other 2 zeros. So when we get to graph these, and this is where we're heading, right? This is where we're heading toward. When we go to graph, we got to find this 0. We'll find it by factoring. We'll then try to factor what's left. It won't. We'll use the quadratic equation. We'll get this 0 and this 0. And that's how we'll start the graph, with those 3 points. We will then find a point down here. We'll try to find a point in here, a point in here, and a point up here, and that's how we're going to graph the thing. That's what it's going to take if we're going to graph. Let's see, is my eraser going to work? Oh, beautiful. Keep me from erasing what I don't want to get rid of. Okay? So that's the base graph. All right, let's take a look at our next situation. Again, I don't have green here, so which is a pain. So I'm just going to go to black. All right, so the next function in your list is a negative out in front of everything, right? The x cubed, and again, this is on your paper. So the whole difference is that negative in front. Everything else is exactly the same. So what are you expecting of the graph? we're expecting it to be mirrored or reflected, right? All right, so now we'll answer the question whether it's reflected about the y-axis, right, a mirror this way, or whether about the x-axis, a mirror this way, okay? So whether it's up to down, that's about the x-axis, or left to right, that's about the y-axis. So here's the answer. And the answer is still hard to tell. That one is still symmetric. Oh, bummer. All right. We'll try the next one. Let's see. Nah, you know what? Okay, if you took this and did it this way, this should be further that way. It's the x-axis. It's the x-axis. Okay? It is reflected about the x-axis. Yeah, if it went the other way, this should be further this way and overlap a little here, but going that way. All right, so it's about the x-axis, reflected about the x-axis. Good. We've got the answer to that. Okay? And everybody's sketching, and these are the tendencies you're trying to learn. Okay, so again, now we're going to have a new base model. Let me clear my ink. And now our base model is y equals x to the fourth. Okay, so we've got an even power, so we're expecting it to end. I'm sorry, we had an even power, expecting it to start and end the same way. It's positive x to the fourth, so we're expecting it to end positive, so it's got to begin positive. It looks kind of like a parabola, but that's only because it's such a basic to the fourth power. It can have up to 4 directions, does it? No, it just has 2. Can have up to 3 directional changes. Does it have 3? No, it has just 1 directional change in 2 directions. Okay, so then we get to the second one there. And we got y equals x to the fourth plus 3. So what are you expecting to happen here? Y equals x to the fourth plus 3. And what are you predicting? Say it if you know it. Okay, hopefully every output then is going to be up 3. And that's exactly what's taking place. Three higher. No matter what point you pick from the red one, the blue one, that point on a vertical line is going to be 3 higher. 3 higher, 3 higher, 3 higher, and 3 higher. Okay? So everything is 3 higher. All right, how about the next one? Next one is y equals the quantity x plus 2 quantity to the fourth. So now you got y equals x plus 2 to the fourth power. So what are you expecting to happen to the red one? Again, red is the base, but now we have a quantity x plus 2. So what are you expecting to happen? Say it if you know it. Move 2 to the left. All right, and that's what should happen. And indeed, that is what takes place, right? So now, no matter what point you pick, move it 2 to the left from the red and you'll get the black. No matter what point you pick, move it 2 to the left and you've got the black. Again, you're just sketching. It doesn't have to be perfect. You're just giving an idea of the moving to the left. If I were you, I'd be writing with my notes, you know, these thoughts, right? 2 to the left. Last one was, what, 3 up and such, because that's the key that you want to understand and realize. Okay, so then the last one here, and again, I got to use blue again because I don't have green available. You've got y equals negative x to the fourth. And what are you predicting on this one? mirrored about the x-axis, right? So it should just flip upside down, and that's exactly what takes place, right? Mirrored about the y-axis. Okay, and again, that's because of that negative. It just flips everything right down. Okay, next one. Oh, keep graphing them. Get out of there. All right, the next one is y equals x to the fourth minus 3x cubed minus x squared plus 3x plus 1. Again, it's on your paper. It's on your notes. So we look at the lead term, and the lead term's positive, and so we expect this thing to end up doing what? Heading to positive infinity. The lead term's exponent is even, so we expect it to start and finish how? The same. All right, so we know that. We expect up to how many directions? 4. And therefore be less than or equal to 3 directional changes is possible. All right, we know all that going in, and so the graph of this one looks like that. And again, you're just sketching. You're just making a sketch in your notes, something similar to that. So sure enough, it does end up heading to positive infinity. Sure enough, it does begin and end the same. How many zeros? There are 4 zeros, right? So you got these 4 zeros here, and this would be a pain to graph because not even that one is actually right at the 3. So none of them are whole numbers. That means with this polynomial, and again, you got a 1 on the end, so you would try the remainder theorem, you would try f of 1 or f of negative 1, and neither would work, and there are no whole number factors. And so this one, you wouldn't be able to find any of the zeros yourself. So how in the world are you going to graph it if you can't find any of the zeros? What are you going to do? Say, I'm stuck, right? That's what you're going to write, I'm stuck. Can't find any zeros, I'm stuck. How are you going to graph it? How are you going to graph it? Did I hear XY chart and all that? How else are you going to graph it? What did you say? Quadratic equation, not quadratic. All right, doesn't factor. Can't find any zeros. How are you going to graph it? Anything can be graphed using an XY chart. You're just going to have to do a bunch of points, though, to figure out where in the world it's at. And it's going to take a lot. But look, aren't you expecting it to end heading to positive infinity? Aren't you expecting to begin and end the same direction? Aren't you expecting up to 4 directions? So in expecting that, when you do your XY chart, make sure you end up with that. I mean, don't do this. Don't get this point here and a point down here and a point up here and say, oh, I got enough points, and I think I'll just draw it like this. All right? You don't want to do that. You don't want to do that. So again, you're just going to expect that many points. Go away. You're in my way. Go away. Go away. Go away. It'll go away sooner or later. Now we're in great shape. I have no idea. Oh, that's probably the new one, huh? All right, there we go. Go away. All right, so look at the next one. And again, I don't have green here. I'm going to use blue. So the next one is that exact same function with the negative in front. And by this time now we're good, and we say immediately what's going to happen? Mirrored about the x-axis, right? And sure enough, there's that mirror. Pretty, isn't it? Nice and symmetrical. It's awesome. It's beautiful for spacious skies. Joanna, say again? Mirrored about the x-axis, yes. Take this red one and flip it like that. Take the red one and flip it from up to down. Mirror it about that x-axis. So let's see. Let me just be clear for you guys. If I had something like that to mirror that about the x-axis, I shouldn't have gone up that high. Would be like this. That would be the mirror, okay? About the x. Got it? If it were about the y, it would go like that, right? Mirrored about the y. Okay, let's get to the last few, and then we got to get to some real problems. Clear the ink. All right, here we go. Okay, last base model, y equals x to the fifth plus 3x to the fourth minus 2x squared minus 4. Again, you guys have that in your notes. We're expecting this to end toward positive infinity. We're expecting it to start and finish how? Opposite. It's a 5. That's odd. It's opposite. How many possible directions? 5. So it can be less than or equal to 4 changes. And there's the graph of that one. Just the way it goes. 1, 2, 3 zeros. Again, none of them are integers. This would have no factors again. And you'd be all XY chart if you had to graph this one. Okay, for time's sake, the next one, hopefully you're thinking is a mirror because it's got a negative in front. And it is, right? Mirrored about the x-axis. And the last one is y equals x to the fourth minus 5x squared plus 4. And you might not have that on your paper. So we'll just watch. So this last one, we're expecting it to end to positive infinity. We're expecting it to start and end the same, up to 4 directions. And math is nice and orderly, so sure enough, that's exactly what takes place. Hey, this one would be great for me to give you, right? How many zeros on this one? 4, and they're all integers. So this one came from the factor, right? This one came from the factor x plus 2. This one came from the factor x plus 1. This one came from the factor x minus 1. And this one came from the factor x minus 2. Because guess what? You could factor this thing. Minus 4 minus 1. This is squared. And difference of two squares. Square root of the first, square root of the last. There's those 2 zeros. Difference 2 squares plus the middle one minus the middle of the other. Square root of the first, square root of the last. There's the other 2 zeros. So again, if we were graphing this, we would first plot the zeros and then we go from there. All right, let's get to it then. So wherever Smart Notebook ended up. Oh. All right, is that your next one? All the way to D? 2, I'm too far ahead. All right, one more. Oh, way back. All right, here we go. I'm going to roll like the wind. All right, so how do you graph third degree or higher? Find the zeros. That should have been green. Oh, this thing's not working now. Find the zeros. Smart Ink is in control. I love it. It's saying green. Give me green. Give me thin. Find the zeros and graph them. What are you going to do next? Using XY chart. To find points before, left of the first zero, between the zeros, and to the right of the last zero. And by the way, I've been clear enough. What if you can't find any zeros? What do? Just go right to the XY chart. And of course, connect the points with a smooth curve. Connect the points with a smooth curve. So find the zeros, plot the zeros, find points left, between, and right, and then connect with a smooth curve. All right, so you look at the first example. It's a cube. I'm expecting this thing, and it's positive, so I'm expecting it to end toward positive infinity. I'm expecting it to start and end in different directions. I'm going into the graph with that thought in my mind. I'm going to now find the zeros, so I want to factor. Thankfully, this thing factors, right? It's not going to cooperate. Got to do it this way. So I can factor out that common x. Don't miss that. I mean, that's a whole lot easier factoring out that common x. I'll go a little higher for you. And now we're going to look to factor the remaining trinomial, right? And it factors into -4, +3, right? Will give me that -1 in the middle. So now we just found the zeros from this one, x equals 0. From this one, x equal -3. And from this one, x equal 4. Again, you would set each parentheses equal to 0 and solve the little equation. Okay, so that's what we want on our graph. I want a 0 at 0. I want a 0 at -3. And I want a 0 at 4. Now you can tell I modified the y-axis on this graph, and you'll see why in a moment. It'll give us a little bit of a distorted view, but we just got to live with it. It's just the way it is. XY chart from here. Okay, some of you are helter-skelter in your lives. Others of you are orderly. I try to be orderly. I start at the left and I work my way to the right. Okay. Again, you can be all hit and miss, but you got to figure out what it does to the left of the first zero, what it does between zeros, what it does to the right of the last zero. So I'm going to start with f equaling, or x equaling. I got to go to the left of the zero furthest to the left. So I'm going to use x equal -4. Yes. Now, by the way, you can put -4 into the original function, or you could actually put it into the factored form, being we have everything factors nice and easily. It's a little quicker, actually. You can do it in your head. -4 plus 3, that second one is a -1. The back one is a -8. -1 times -8 is 8, and there's a -4 in front. -4 times 8, -32. Or you could simply punch it in your calculator. Parentheses, -4, parentheses, quantity cubed, minus, parentheses, -4, quantity squared, minus 12, parentheses, -4, and your calculator will say -32. All right. I know this point is at -32, which is about right there, right? Am I coming up from -infinity like I expected? Yes. Cool. All right. In between, unfortunately, I got to do a couple values here. I'm going to do -2. So again, I can go off the original, or I can go off the factored form. If I went off the original, it's one way, but I think it's easier going off factored form, to be honest with you. So the first parentheses is a 1. The back is a negative 6. 1 times negative 6 is negative 6. And a negative 6 times a 2 is a positive 12. Negative 2 is a 12. And I'm up to 12. I'm going to do negative 1. And at this point, for time's sake, does everyone understand how I'm getting the y values? I'm either putting it into the original function or I'm putting it into the factored form of the function. All right, so the next point's going to yield 10. So negative 1 is 10. My next 0 is the 0. And for time's sake, I went for 2. 2 is a negative 8. So graph 2, negative 8. And I graphed 5. I did 5. And 5 is 40. Right there. Did it end up the way we expected? Is it doing what we thought it would do? It is. And again, you're just trying a smooth curve. Is this going to be 100% accurate? No, you'd have to do a lot more points to get it even finer, but it gives you a rendition, a representation of that function. It's beautiful. It's a regular work of art. Okay? Questions on that? Can you do that? Hopefully you can. All right, next one. Graph f of x equals x cubed. Look, this is x times x times x, right? So a 0 is x equals 0, right? Got to remember that my color has to change there. So I've got that point. Do I have any other zeros to find? The answer is no. So what am I going to do next? Next, I'm going to have to do my XY chart. And again, that's what you would do. And I'm just going to do this very, very quickly for time's sake. But in your XY chart, if you did negative 1, you would get negative 1. And your point's right there, right? And you know what? I look at that and I say, you know what? I really should have another point on that side. And I did negative 2. And I got negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Right down there. Not a problem. It does show me it though. I did 1 and I got 1. And I did 2 and I got 8. 2, 3, 4, 5, 6, 7, 8 is right at the top on that side. And it's what I was expecting. It's ending toward positive infinity. Starts and finishes opposite. Up to 3 directions. This one only had 1. Okay, so again, you guys are already turning pages, but don't forget, this is a 4 added to the base. So I know that's going to be up 4. And this one is going to be right 2, right? 4 and right 2. Up. And then didn't see the other part there. And I lost my ink. Come back, ink. Oh, now you're gone, huh? Wonderful. Oh, you're really doing crazy stuff here. Okay, and then we're also down 3. I can't even write here. Down 3, whatever. All right, let's go to the next slide. Okay, so in this one now, this one's not going to factor right off the bat. And now we've got to do what we've been learning. And that is how to factor something like this. And now it's a full-blown problem. So how do we start that full-blown problem? We start it with trying to factor, right? And therefore, then we're going to say, I got to figure out what factors to try, and I got a -5. Thankfully, I got a 1 in front. So what are all those possible factors? X plus 1, x minus 1, x plus 5, x minus 5. And therefore, then we're going to start trying to divide them into the original. And you can sit there and try and try and try and try. But here's the reality. None give a 0 remainder. None of them give a 0 remainder. So what are you left to do? You're left to do an XY chart. And you are looking at your predictors, right? This thing is a positive lead term. It's going to end to the right. It's cubed, so it's going to start and end opposite. And I'm going to go from there. All right, again, for time's sake, when you use 0, you get -5. When you use -1, you get -10. When you use -2, you get -29. Does that look like it's coming out of negative infinity? That looks pretty good. When you use, oops, I already did 0. When you use 1, you get -8. Use 1, you get -8. And I need more points, right? When I do 2, I get -13. When I do 3, I get -16. Oh man, this thing's still going down. All right, I got to get that last directional change right because I'm expecting it to end to the right. So 2 gave me negative. Again, you're listening to the points, right? You're doing the XY chart. You know where -8 is, 2, -8. And you know where 2, -13 is. And you know where 3, -16 is. But I'm still going down, so I got to do another point. So I do 4, and I get -5. Okay, this thing is finally going back up. And I could quit there, but I'll do one more. I do 5, and I get 20. Now I'm comfortable with the look of my graph. A little higher for you guys. And again, just connect your points with a smooth curve and something like that, right? All right, last one. Last one. Again, a full situation here. You've got to find the zeros, right? You got a 12. Now, thankfully, the lead term is a 1. So, but you got plus or minus 1, right? Plus or minus 2. Plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, right? As possibilities in the 0 remainder factor. So, to speed everything up, let's try an x plus 4. So everywhere where the variable is, we'll put in a -4. Because again, I'm thinking of all these possibilities. And if you add all that up, it worked. You got a 0 remainder. What would you do next? Say it if you know it. Long division. Good. So you're going to take your x plus 4 now, and you're going to divide it into the x cubed minus 3x squared minus 7x plus 12. A long division. For time's sake, we've done long division. You get x squared plus x minus 3 with what kind of a remainder? None, right? X squared plus x minus 3. I would now look to factor that, correct? Here's the problem. Doesn't factor. What do I do then? Now you got to use the quad equation. And when you do, you end up with x equal plus or minus, negative 1 plus or minus the square root of 13. That's negative 1 plus or minus the square root of 13 over 2. Is that a graphable form? So you're going to have to get the decimals. Just use your calculator. This is a positive 1.3 and a negative 2.3. Okay, good. Now I know my zeros. I got a 0 at negative 4. Right? I got a 0 at negative 4. I got a 0 at positive 1.3, roughly right there. And negative 2.3, roughly right there. Right? And now I got my zeros. I know what to predict on this curve. I know now to find zeros left, or values left, between and to the right of my zeros. And I'm going to sketch my curve. And again, we don't have enough time to deal with this, but that's the graph. Hunter.
When you're doing long division, if you put x times x squared equals x cubed, so then 4x squared would be positive, and you have to subtract it, so it would equal negative 7x squared.
Yeah, I see in my haste, I gave the backwards here, so let's fix this real quick. This is an x minus 4 here, and therefore these are all positive 4s, and that's what gives you the 0, and this is a negative. So that other 0 is an x equal 4. And again, for time's sake, if you were to graph this, it would look something like this. Something like that. Thank you. Good. Paying attention. Awesome. Okay, again, 2 days. I know I went fast at the end, but these are all things that we've done already and we know how to do. We know how to factor. We know how to use a quadratic equation. We know how to do an XY chart. We just have to put it all together to understand how it all fits in the graph. And I hope that made sense for you. And so tonight, your homework is listed, right? You can't take off. Now you got Monday as well. That test is coming Thursday next week. I hope you'll be ready. All right, have a great weekend.